Assalamu alaikum and hello everyone. Today we will present our video presentation about techniques of differentiation for MAT 183 Calculus 1. And this is my group member. The first one is Siti Alawiyah binti Sanusi. The second one is me, Muhammad Shazwan Fakrullah. And the last one is Siti Natasya binti Mokhtar.
Introduction and Problem Statement Question 1. Explain the meaning of differentiation and what are the techniques of differentiation.
What is differentiation? Differentiation in MAT 183 refers to the mathematical process of determining the derivative of a function. The derivative of a function f(x) at the point x is defined as f prime x equal to limit h approach 0 fx plus h minus fx over h. This limit, if it exists, gives the rate of change of the function at that point and is known as differentiation from first principles. Differentiation is used to analyze how a function changes with respect to its variable and is fundamental in solving problems involving rates of change, optimization, and curve sketching. Let's move to the next part. What are techniques of differentiation in calculus? Differentiation in calculus involves various techniques to compute derivatives efficiently. These methods are foundational for analyzing rates of change, optimizing functions, and solving real-world problems. And below there are four different key techniques for differentiation. The first one is power rules. Power rule is used to differentiate functions of the form f(x) equal to x power of n. The power rule states d over dx, x with the power of n minus n x power of n minus 1. The second is quotient rule. The quotient rule applies to function expressed as a quotient. If fx equal to u over v, then d over dx is equal to u prime v minus u v prime over v squared. The third one is product rule. For functions expressed as a product of two functions, if fx equal to u multiply v, then d over dx is equal to u prime v plus uv prime. And the last one is chain rule. Chain rule differentiates composite function f, g, z. dy over dx is equal to dy over du multiply du over dx. So here, there are two more different techniques for differentiation. Implicit differentiation. Implicit differentiation is used when a function is defined implicitly, given x squared plus y squared is equal to 1. D over dx plus d over dx equal to d over dx, and it's become 2x plus 2y multiply dy over dx is equal to 0. And for solving dy over dx, is dy over dx is equal to negative x over y. And the next and the last one is higher order derivatives. Higher order derivatives computing derivatives of derivatives. Acceleration is the second derivatives of position. F double prime x is equal to d over dx f prime x. These techniques applied in physics and engineering for analyzing motion.
Problem statement question 2. We need to find dy by dx for the following function. For question A, we were given dy equals to exponent to the power of 2x multiplied by x squared plus 5x raised to the power of 3. In question B, we were given y equals to ln x plus 1 divided by sin of 4x. To solve question A, let u equals exponent to the power of 2x, then u prime equals 2 times exponent to the power of 2x. Let b equals to x squared plus 5 cubed, then b prime equals to 3 times x squared plus 5x times 2x plus 5. Then using the product rule, which is dy over dx equal to uv prime b plus uv prime, then substitute to get the final answer. Let u equals to ln of x plus 1, so u prime is 1 over x plus 1. Let v equals to sine of 4x, then b prime is 4 times cos of 4x. Substitute the value into the formula to get the final answer.
Problem Statement Question 3. Given 2y over exponent 3x minus ln x plus y equal to sec 2y plus 5x. Find dy dx using implicit differentiation.
Given the equation 2y over e to the power of 3, x equals natural log of the quantity x plus y minus second of 2y plus 5x. Our task is to differentiate both sides of this equation with respect to x. Step 1. Differentiate the left-hand side. The left-hand side is a fraction, and it's a quotient. To differentiate it, we'll use the quotient rule, which states the derivative of u divided by v is equal to v times the derivative of u minus u times the derivative of v and all over v squared. And in this case, u is 2y, and its derivative with respect to x is 2 times dy by dx. And v is e to the 3x, and its derivative is 3 times e to the 3x. Now applying the quotient rule, we get e to the 3x times 2 dy by dx minus 2y times 3e to the 3x, all divided by e to the 6x. We can simplify that to 2 dy by dx minus 6y all over e to the 3x. Step 2. Differentiate the right hand side. Now, Let's differentiate the right-hand side of the equation. We start with the natural log of x plus y. The derivative of natural log of x plus y is 1 over x plus y times the derivative of x plus y. The derivative of x is 1, and the derivative of y is dy by dx. So the total derivative becomes 1 over x plus y multiplied by 1 plus dy by dx. Next, we differentiate negative secant of 2y. Using the chain rule, the derivative of secant of something is secant times tangent of that something, since we have 2y. We also multiply by the derivative of 2y, which is 2 dy by dx. So the full derivative becomes negative 2 times secant of 2y times tangent of 2y times dy by dx. And finally, the derivative of 5x is simply 5. So, putting it all together, the derivative of the right-hand side is 1 plus dy by dx over x plus y minus 2 times secant 2y times tangent 2y times dy by dx plus 5. Next, step 3. Set both sides equal. Now, we set the derivative from both sides equal to each other. So we write 2 dy by dx minus 6y over e to the 3x equals to 1 plus dy by dx over x plus y minus 2 secant 2y times tangent 2y times dy by dx plus 5. Step 4. Multiply through and rearrange. To eliminate the denominator on the left side, we multiply both sides by e to the 3x. This gives us 2 dy by dx minus 6y equals e to the 3x over x plus y times 1 plus dy by dx minus 2e to the 3x times secant 2y times tangent 2y times dy by dx plus 5 times e to the 3x. We now rearrange the equation to group all the dy by dx terms on one side and the constants on the other side. After simplifying and moving terms around, we factor dy by dx from the left-hand side. We end up with dy by dx times the quantity 2 over e to the 3x plus 1 over x plus y minus 2 secant 2y times tangent 2y equals 5 plus 6y over e to the 3x plus 1 over x plus y. And the last step, step 5, solve for dy by dx. Now we isolate the dy by dx by dividing both sides. So the final answer is dy by dx equals the quantity 5 plus 6y over e to the 3x plus 1 over x plus y divided by 2 over e to the 3x plus 1 over x plus y minus 2 secant 2y times tangent 2y. And that's the final result for dy by dx. We use the quotient rule, chain rule, and implicit differentiation to arrive at the solution step by step.
Problem statement question 4. Use linear approximation to estimate the value of fourth root 16.37 plus 1 over square root 16.37. Correct to two decimal places. Problem solution question 4. The given value is fourth root of 16.37 plus 1 over square root of 16.37. So x is equal to 16.37. Then x naught is 16 because we round off 16.37, so we get 16. Next, we find the x using the formula dx equal to x minus x naught, where x is equal to 16.37 minus x naught is equal to 16. We get 0.37. Next, we assume that fx equal to fourth root of x plus 1 over square root x from the value given. So we can assume that fourth root of x is become x to the power of 1 over 4 plus 1 over square root x equal to x to the power of negative 1 over 2. Because 1 over square root is equal to the power of negative 1 over 2. Next, we find f prime x. From fx, we get f prime x is equal to 1 over 4x to the power of negative 3 over 4 minus 1 over 2x to the power of negative 3 over 2. From fx is equal to x to the power of 1 over 4, we can get f prime x by multiplied coefficient of x to the power of 1 over 4 and the power of 1 over 4 minus 1. So we get f prime x is 1 over 4x to the power of negative 3 over 4. To find f prime x to the power of negative 1 over 2, we use coefficient x multiplied by the power of negative 1 over 2 and the power of negative 1 over 2 minus 1. We get for f prime x power of negative 1 over 2 is equal to negative 1 over 2x power of negative 3 over 2. Next, f prime x naught is f16. From the formula f prime x, we substitute 16 to x in the formula, where we get f16 equal to 1 over 4 multiplied by 16 power of negative 3 over 4 minus 1 over 2 multiplied by 16 power of negative 3 over 2. We get 3 over 1 to add. Next, we use fx equal to 4 root x plus 1 over square root x and substitute x equal to 16. We get 9 over 4. Lastly, we use linear approximation formula fx naught plus dx equal to fx naught plus f prime x naught dx, which is fx naught is 9 over 4 plus f prime x naught is 3 over 1 to add multiplied by dx is equal to 0.37. So the final answer is 2.26. Conclusion. Differentiation is a key concept in calculus used to find the rate of change or the slope of a function. There are several techniques to differentiate different types of functions, and each one has its own purpose. The main techniques include power rule, product rule, quotient rule, chain rule, implicit differentiation, and higher order derivatives. Each technique is useful depending on the form of the function. Understanding when and how to apply these rules helps us solve real-world problems like motion, growth, and optimization.